Machine learning is all about building a mathematical function of the form y is equal to f of x, which can be used in solving real-time problems or any problem which will occur. Here y could be a dependent variable, or y could be a variable which is dependent on other variables, where x are the independent variables. And typical scenario, if I can take to explain machine learning example, is let's assume that you want to predict, as a retail banking manager, you want to predict who are my customers who are likely to take or respond positively to a loan campaign. So before doing that, I have collected data on my customers, and this could be data related to his savings bank account, this could be data related to his credit card usage, this could be data related to his demographics, and this could be, in demographics, it's both location, gender and company. Using these input variables, if we have to predict a y variable which says like what is his probability or his propensity to respond to a loan campaign, then this entire thing we actually build a mathematical function of the form y is equal to f of x. So machine learning is nothing but a study of different techniques which helps us to build this mathematical function y is equal to f of x for problems like this. And there could be several other problems and several other applications. Like machine learning today has applications in every field. It has applications in retail, it has applications in financial services, it has applications in internet marketing, it also has applications in pure engineering based application in like image detection and so on. Okay, AI and data science are synonyms to each other. Okay, data science was the most commonly used term way back in 2010 or 2012 when people were actually looking at this discipline. Today the most commonly used term is artificial intelligence. Okay, so both are synonyms to each other, and I'll define what data science is all about. Data science is the art and science of actually collecting data, processing data, transforming data, visualizing the data, analyzing the data, and building some models using the data which actually give you some output that can be useful or relevant in the analysis mind. And if you have the maths and stats mind, okay, this is actually a very common question when I teach data science, or even when I interact with people who are coming from the software industry or even from the non-software industry. All of them have this question: is data science right for me? Or what is data science all about? According to me, and it's my personal opinion, data science can be picked up by anyone. But before picking it up, we need to understand what data science is all about in terms of skill set. In data science, there are three skill sets which you need. One is a programming skill set, second is a maths and stats skill set, and the third is a business analysis skill set. And data science is actually an intersection of these three skill sets. If you think of this and visualize this as a Venn diagram, right, you assume one set is actually programming skills, the other set is actually maths and statistics skills, and the third set is actually business analysis skills. Data science is right in the middle of the intersection of these three areas. So anyone who is actually a business analyst and does not fear mathematics and statistics and has an aptitude to pick up programming easily can become a data scientist. Similarly, anyone who has a very good experience like a BSc, MSc mathematics or MSc stats, who has a very strong mathematical and statistical background and has done some programming in the past, and he is ready to pick up the business analysis skills, he can also be a data scientist. And thirdly, anyone who has a very good programming skills, who have built solutions or software applications using programming languages like Python, Java, any one of these, right? And they have this aptitude to actually look at data, and they have this aptitude to actually to code and actually come up with solutions, then they can actually pick up the maths and stats and also the business analysis skills and become data scientists. So one thing, if I have to tell you, like data science requires all these three skill sets, and data science you need to have an inquiry mind. So you ask the right kind of questions about the data and about the problem which you're solving, because understanding the problem at hand is very key before you actually start doing the analysis of building the machine learning models. Okay, and also understanding the problem in hand will actually help you to generate insights, because ultimately people who are paying for a data science project, it could be your internal to the company or even an external client, he actually pays for the insight which you are giving. So all this mathematics, programming or the analysis which you are doing, if it does not translate to an insight, your job as a data scientist, you have failed. So if you have that business analysis mind, and if you have the maths and stats mind to build the right models, and if you have the programming mindset to actually develop these mathematical models and generate some insights which can be present to the end client, then data science is for you. So today, anyone who comes from a data warehousing background, anyone who comes from a programming background, anyone who comes from a business analysis background can take up data science. But having said that, it's not limited to these areas. If anyone has demonstrated a good aptitude towards programming and also mathematics and can pick it up, he can also take up data science. Skills, and you need to have good logical understanding. So this, okay, data science, again, this is a question I've observed in a lot of forums. I've observed when people also interact with me, because when they come and interact with me, a lot of freshers ask this question: is data science right for me? Is data science something which I should pursue? Okay, coming to picture, yes, data science is right for you. Number one, you should have some amount of prior programming experience. Okay, programming experience doesn't mean that you'll have to do it in a working area like you are part of a company, anything. Even in your college, if you come from any engineering background, or even if you come from a non-engineering background, if you have picked up programming and you have done mathematics fairly till class 11 or 12 and you enjoy mathematics, then you can pick up data science from a orientation or aptitude perspective. Okay. So these two are very important. You should like programming and you should have an aptitude towards mathematics. Second thing, what you may not have as a fresher is your analysis skills from a business context. That is something which you gain through a lot of experience. Of course, reading a lot of business problems, attempting a lot of problems which are there in the net, and probably interacting with the right mentorship, you can actually pick this up. So these are from the aptitude perspective. Second perspective is from the job market perspective. So as a fresher, if I actually do a data science course, will I actually get a job? That's something which everyone has. Let me tell you, you will get a job, because the way this area is going at an astronomical rate, there is going to be a lot of demand for data science, and especially a lot of companies, both big and small, prefer fresh talent because they believe that these guys can be molded or, oriented in a right manner to actually solve data science problems in their specific organization. So companies such as Google, Amazon, or even services companies, IT services companies like Cognizant, Infosys, they all look at fresh talent to come in as data scientists. But please understand, when you get picked up as a data scientist coming from a fresh background just out of engineering college, you will start off as a junior data scientist. And as a junior data scientist, your role could be predominantly not just the cool stuff of building algorithms or building the machine learning models, because the bulk of the data science job is actually handling the data, acquiring the data, pre-processing the data. So you could be having more of those tasks to begin with. And to solve those tasks really well, you need to have good programming skills and you need to have good logical understanding. So this is like a foremost when you start off as a data scientist, a fundamental skill. Apart from that, if you demonstrate any machine learning skills, or if you demonstrate any good skills like understanding of, I won't say advanced, but in-depth concepts of mathematics and statistics, especially in the area of probability, statistics, linear algebra, I'm sure you will get to dabble and build machine learning algorithms. So for you as a fresher, this is a very right opportunity. The salaries, again, this is based on a research given by Indeed as a site. It was a figure which they came after 2 years back. They believe that fresher talent, if they have data science knowledge, coming out of engineering colleges or any other reputed institute which has programming or teacher statistics, they can start off with anywhere salaries between 6.5 to 7 lakhs INR per year, right? So those are the kind of salaries which you can attract as a fresher. And there are companies which pay much more than that even for a fresher talent, and there are companies which may be paying lesser than that. But having said that, this is a huge growing area, and if you start off at that level and then you can progress yourself, initially as junior data scientist, then as a data scientist, then senior, then principal data scientist, I'm sure it will be a fabulous career for you to actually pursue. Okay, for a fresher or a working professional, the skills which you require to be a machine learning expert is threefolds. First and foremost, you should have the skill set of acquiring data from multiple sources and pre-processing or transforming the data. When I say multiple sources, this is not just your internal or SQL based databases from where you are acquiring this. It could be even data which you are actually getting through web crawling. It could be data which you are acquiring through APIs, and you're creating a data pipeline to extract this data in a seamless fashion. It could also involve actually taking data from text or images and combining it with structured data sources, which is coming from SQL databases. So data acquisition is a big skill set. After data acquisition, the next big skill set which you need is, whenever you're doing the analysis or going to build the machine learning model, you need to have a common frame of data. Okay, this could be either a CSV file or a JSON file, which most of the machine learning algorithms can actually take. So building this common frame of reference, that is combining data from multiple sources, and when you're combining transforming data is another skill set, which may be coming under the area of data pre-processing. After you combine this data from multiple sources, you will have to check for the data validation. Like, is there any data which is missing? Is there any data which is, from a statistical perspective, we have something known as outliers. So we'll have to check based on certain rules like that, and again apply certain transformation techniques on the data. After doing this, the next thing which you need to do as a fresher or an experienced person, which your data science job requires you to do, is actually visualizing and analyzing the data as much as possible. When I say visualizing, you may have to generate a lot of charts. If I remember one of my previous assignment, we generated close to 150 to 200 different charts to understand the intuition about the data, and this was typically a large data set which had a lot of variables. When I say a lot of variables, imagine a CSV file, a large data set having a lot of records. Let's assume a records more than 1 million records. At the same time, it had a number of columns or different attributes on which each record could be described. So the number of attributes here are also 100 plus. So obviously we did not take the entire data set to do the analysis, but we had to take the sample of the data set and do the analysis and visualization. So this is something which you need to do. Post this is what you actually build the machine learning model. And when you are building the machine learning model, apart from this data acquisition, data pre-processing skills, you also need to have some mathematical and statistical skills to choose what is the right kind of model which I need to build. Or even if you choose a model, what are the advantages or disadvantages of the model? What are the inefficiencies in this technique? So you need to have that mathematical knowledge before building this machine learning model. And also, after you build the machine learning model, you need to evaluate the machine learning model on certain mathematical parameters. So when you are evaluating it using accuracy or learning curves, again the maths and stats is important, and you also need to have an expectation, like for the kind of problem which you are building, whether the kind of accuracies or what you are achieving is something which makes sense or not. Post this, after actually building the machine learning model and doing the insights, you need to generate the insights, and these insights have to be in a form which is presentable to a business user who does not understand data science or does not understand data analysis. So the result of your machine learning model, the result of your analysis, how do you present it? That's another skill set which you need to have. So in a nutshell, if I have to summarize, you need to have data acquisition, data pre-processing, data visualization. Okay, you need to have mathematical skills, you need to have machine learning skills, and apart from machine learning skills, you also need to have good business communication skills to represent the insights of your model or your analysis and actually get a sign off on the project. So hopefully that should answer your questions. Thank you. So do your integration in Python. So I'll give you some background before I answer this question. Many students ask me this, hey, should I pursue in R or Python? Okay. Before we answer this question, let us look at from the market perspective. If you look at most of the jobs which are out there, okay, which say there's advertisement in job boards like, hey, I want a data scientist, they will ask that they want you to be good at both R and Python both. Okay, that's something which you will notice. So as a data scientist, okay, you can start off with one language, and as a data scientist, people expected from the market is you should be having this cool ability of picking up different programming languages and able to code in the same within a short time frame. When I say short time frame, it could be something as low as 2 weeks to probably 1.5 months. So people expect that you have that ability to pick up programming languages easily well. But having said that, both these languages are popular. And to give you some background about R, okay, R started off in Bell Labs as S, and later it became R. And predominantly the strength of R was, it is a language is used predominantly by all the academicians who come from the leading universities or pursuing PhDs. So most of the advanced mathematical concepts or any new algorithms, there is a likelihood that it is likely to come out as a library first in R than as compared to any other language. So that is the huge advantage of R. And R, as I said, it is fairly robust. It integrates with big data platforms like R Hadoop and Spark, and is also used by large companies. Like R is used in, as far as I know, I'm not sure at the present information, but previous information said that R was used by Google for the internal analytics, for internal reporting and everything. And R was also used by Twitter to a large extent. So that is the strength of R. Now coming to Python, Python is also a very robust language, and one difference between Python, but not from the machine learning or data science concept, but as a language in itself, Python is also object oriented, and you can actually build general engineering applications which you would have done in Java. Same things can be done in Python. Python can be used as an effective backend integration server tool as Python Django. Python can be used as a machine learning tool or a data science tool using libraries like Panda or MLib or any of the other machine learning libraries. So Python definitely has a wider set to offer than R, because it's not just data science what you can do in Python. You can do all your backend jobs in Python, and you can also do your integration in Python. So that way Python is very, very robust, right? So there is an advantage of Python which it has. But from the machine learning and data science perspective, both are actually good enough. And one area where Python may have a slight advantage over R is when it comes to the area of text processing and text mining. So it just happens like most of the natural language NLP algorithms or any text mining algorithms, Python does have little bit more libraries to offer, okay, as compared to R. And it's just a standard in the market, like people whenever they do text mining applications, they prefer taking up Python, because most of the libraries for text mining initially were written in Python first. At least a good number of them from a perspective of being used by engineers across the globe. It was much more easier to do in Python as compared to other languages. But having said that, there are text mining algorithms in Java, R and other languages as well, but Python is like more like a preferred standard. So that's why probably in text mining applications or text analytics applications, Python seems to have a preference over R. But overall, if you look at the overall scheme of things, as a data scientist, I suggest, right, you should actually have good knowledge in both these packages, and you should be versatile in using the language as and when the situation arises, depending on the client requirement. Or you might say like, hey, as a team, we are better off as a team to do this in R, so let's do it. We are much more faster in executing this. So that is a call which you or your team members will take when implementing this data science application. But overall, both are something which you should pick up as a data scientist. So if you look at organizations, right, you should pick up both Python and R, because many organizations, depending on the application, the client or what it is, as a team they might decide to do the application R or Python. So if you are a data scientist, and you should have the versatility based on the decision which your team has taken to code or build a solution in the right language. So I suggest that as data scientist, you can start off with picking up one programming language like R or Python, but later also develop your skill set in the other one as well. So that's what I will say as a data scientist, do that. But data science, again, as I mentioned, it's not all about programming language, it's also about developing a maths and stats skills and a business analysis skills. So develop those two areas as well apart from your programming skills. Thank you. What is the problem which you, okay, very interesting question. Many people have this question. They ask like, what is big data? And second thing they ask is big data and data science or machine learning go hand in hand? First and foremost, I would like to tell you, like, definitely we are in that time of human evolution where we are generating a lot of data, okay, and these data points which are getting generated is not just internal to the organization but external to the organization. When I say external to the organization, you have data which is actually being generated in social media like Twitter or Facebook. You have data which is being generated in terms of customer feedback, in terms of reviews. You have data which is being generated in terms of blogs. And if you look at the data generation and the different forms of data generation, predominantly 70 to 80% of the data which is being generated is actually text data. After that, we have other forms of data as well, like image data is another form of data, video data is another form of data, and of course we have the structured data formats, which I say, like when I say structured data formats, these are transactional data or any other form of data which is kept in a SQL based database. So we have all these different forms of data. So you as a data scientist, of course, you need to understand how to handle these different data frames, and also when you need to understand is the volume at which this data is getting generated in these different areas. So your traditional SQL based databases do not serve the purpose anymore. So you will need to keep this data in a big data basis. One is from the storage perspective. Second is from the perspective of keeping a replication of the data in many copies. So there is a fail-safe mode that if one copy of the data is destroyed, you have another copy to fall back. Third is, of course, when you are processing this data, you would like to process this in a distributed and a parallel computing environment. That's where big data really comes in. So you have big data areas like Spark and Hadoop. So this should actually give you a picture why we need big data platforms. One is the volume of data being generated is huge. Second, if you want to process this large volume of data, you will need a different parallel and distributed computing architectures or computer frameworks, for which you have this big data framework such as Hadoop and Spark, and that is the reason why you need it. But having said that, if you look at most of the problems which you are really going to come across in many of the organizations till date are not big data problems. But big data, if you know as a data scientist, is definitely a big plus. But big data problems are pretty much still not majority of the problems which you will face as a data scientist or as a business user who wants to analyze data to generate some insights. So big data problems are definitely there, and if I can take it from an industry perspective, okay, coming to big data, when you look at large internet companies such as Google, Facebook, they generate a lot of data. So any analysis which is done on the data, you have to know how to handle large amounts of data which are in gigabytes or petabytes. So you will need knowledge about frameworks or platforms such as Hadoop or Spark. But having said that, most of the problem which you guys will come across as either a data scientist or someone who is a big data analyst is data which is not that large in size. It could be much smaller in size, and this could be data even because whenever you do the analysis or build the model, you build on a sample of data. The sample of data could be definitely less than 1 GB or 2 GB of data, which again falls in the small data paradigm. So analyzing that data should not be really a challenge for you. So as a data scientist, if you ask me like, hey, should I know big data? I will say, hey, if you know big data, it's definitely a big plus. But please understand that big data itself a huge area. Okay, it requires 3 months to 6 months to master it. Data science is also a huge area which requires 3 months to 6 months to master it. So if you are someone who is trying to actually employ themselves in a very short time frame, then if you are trying to master both of these, it's going to take you at least 6 months to 10 months, even with all your best of abilities and the best of attention or orientation and the best of efforts, going to take you 6 months to 10 months to master both of them. But if you look at one of them and you want to master one of them and actually get a job quickly, probably a 3 months to 6 months time window is what it is all about. So most of the companies which are in the financial services, telecom, I will say retail vertical, some of them problems over there, not all problems, are definitely problems which are not in the big data paradigm. But having said that, there is a very good chance that, especially when you combine data from multiple sources, because that is what as a data scientist you are required to do, like not just build a data science model or machine learning model on structured database, but data which is actually combining a structured database from data which is like text data coming from social media. In all such kind of areas where that is going to happen, you may have to actually handle large amount of data which may fall in the big data ecosystem. But the point of proving the model or building the model in the initial POC stage will predominantly be in the small data phase, but probably in the deployment phase when you are actually whatever model which you have built and you're deploying it, then it could be in the big data. So it's good to have the big data knowledge, but for you to start off and to actually make yourself employable, you can start off by picking up the data science knowledge and then pick up big data after some course of time. Okay. Deep learning today is a buzzword, and many people, both freshers and even experienced people, when they're pursuing a data science course, they have this question, what is deep learning all about? To answer this question, first I'll tell you what deep learning is all about from a theoretical perspective. A deep learning refers to any machine learning algorithm or any machine learning application using a deep neural net. And when I say deep neural net, it is nothing but a neural net which has multiple layers. And now you may ask me, what is a neural net? A neural net is nothing but a machine learning algorithm which is modeled after the neuron of a brain. And how does a neuron of a brain work? A neuron or a single cell in a brain has input signals which come in. It sums up those input signals and gives an output signal. Similarly, in a neural net, which is made of many units known as perceptrons, each perceptron is actually synonymous or mimics the behavior of a neuron or a neural cell in our brain. Each neuron in a neural net or each perceptron in a neural net It takes in input signals from many sources. It sums up those input signals. After summing it up, there is something known as an activation function where it transforms that summed up input into, it transforms or activates or that summed up input into another form and gives that as output. Okay. A neural net is nothing but a machine learning algorithm which is made up of many such perceptrons. Now these perceptrons can be in one layer. Okay, one layer is all of them are having the same input signals coming in, or it can be in an intermediate layer, or it could be in output layer. Output layer is one which gives output, or the output of the entire neural net. So now if the number of layers, instead of being 3, like 3 or 4, where there is an input layer, the intermediate layer and output layer, if there are several like 30, we typically say it's a deep neural net. And any machine learning or any learning which is happening using a deep neural net is known as deep learning. And there are two different popular deep learning frameworks, or I will say architectures. One is a convoluted neural net, another is a recursive neural net. And when we actually build a deep neural net, one essential difference from other machine learning problems what we are attempting over here is we are trying to mimic the behavior of the human brain. Okay. In other machine learning algorithms, we are probably doing a classification, we are doing a prediction, we are doing a forecasting. Okay. Whereas in a deep learning neural net, we are trying to mimic the behavior of human brain. And what, especially if let's take an example, human brain is actually very powerful. Today, it is able to identify an image in a collage. Let's say the human eye is actually able to is shown an image of which has multiple objects. It is able to accurately identify what each object is. Let's say an image which has people, chairs, tables, computers, projectors, doors. So human brain can just look at an image and tell you instantly, hey, this part of the image is a computer, this part of the image is a chair, this part is a human being, and so on and so forth. If something similar has to be done by the computer, it's actually a major challenge. All machine learning algorithms fail. So now we have something known as a visual cortex of a brain. That part of the brain is linked to the eyes, which is able to identify this easily well, since the human brain has actually learned the different patterns based on years and years of experience, which we have developed as kids. Because that's why as kids we keep asking these questions like what is this object, or we keep exploring what different objects are, and the human brain is able to do it. Now if the computer has to do the same thing, first it needs to be trained on several images, millions and millions of images, and the way it can be, this visual cortex can be simulated is through a convoluted neural net of multiple layers, okay, which is actually built, and these multiple layers are able to identify features specific to different objects, and based on the features with respect to different objects, there is a output which is coming out saying that this object belongs to, this part of the image belongs to a human being, this part of the image belongs to a computer, and so on. And when I say features, these are image features. Okay, features could be the thickness of the thickness in terms of color or contrast. Features could be sharp lines in the images. Features could be distance from probably from the corner of the image. It could be anything like that. So these features are analyzed, and based using those features, the deep learning neural net, like a human visual cortex, is able to identify what are the different objects. So any behavior like that, where deep learning is actually becoming popular, is where they would want to mimic the behavior of the human brain. Another popular application of deep learning is auditory cortex, where speech transcription to text is happening using a deep learning neural net. But having said that, deep learning neural nets require large amount of data to actually train it, and to come up with an architecture of a deep learning neural net, it takes a lot of effort to do it. And today, if you look at most of the leading tech companies like Google, Microsoft, they have developed a deep learning architecture already. They offer that to us, for us developers to actually access, manipulate and use it for our applications. And deep learning is only useful where you want to mimic the human brain and where you have large amount of data to train it. And especially this is true for most of the application in text or image, where you want to, let's say you want to understand the meaning of the sarcasm in tweets. You may want to build a deep learning neural net for it. And the same example which I have told, you want to understand the different objects in an image, or you want to identify who the person is depending on his walking style. Stuff like that, which human beings are able to quickly identify, and the human brain is able to do it. Deep learning is useful. But for applications which I mentioned in my earlier sessions as well, applications such as where you want to detect whether a credit card fraud is happening, or you want to detect whether a person is going to take a personal loan or not, or is going to respond to a marketing campaign or not, or applications where you are kind of making a prediction whether this person is going to end up in emergency room kind of situation in healthcare. These applications can be built with simpler algorithms. You don't need a deep learning neural net. You can do it with deep learning neural net, but they can be done with much simpler algorithms. And in data science or anything in machine learning or any practical exposure which we have, we follow the Occam's razor principle. The simpler the model, the better. So where we can solve the application or the problem effectively as a data scientist with simpler algorithms, we do it. And where we want to mimic the human brain, where the problem is pretty complex and we need to understand the different variability and we have lots and lots of features, we'll go for a deep learning neural net. Thank you guys. Payer or the insurance. So people ask me this question as a domain expert, what are the different applications of machine learning, data science or big data? So firstly, when you say domain expert, I would like to clarify that domain expert is in two areas which you actually talk predominantly. One is you can be a domain expert in a particular industry. Okay, like you could be a domain expert in healthcare, you could be a domain expert in telecom, you could be a domain expert in financial services. From the virtue of the past experience which I had, fortunately or unfortunately, I can say myself as a domain expert in the area of AI and big data, but not as a domain expert in any particular industry, because at the same time I got to do a lot of proof of concepts across industries. One interesting concept which I actually did, which can actually give you a good insight about what kind of machine learning or data science application can be built in healthcare, is a problem which I actually solved for the US healthcare market. So we built a US population healthcare management system, and just to give you some context, and when I give this context, hopefully some of you guys will appreciate any data science application or any AI application which you build, the business domain knowledge is very important, that you understand it really well. So knowledge of that area, you may not be an expert like having worked in the industry for 2 years, but you will have to pick up at least the working knowledge before building it. So that's you'll also be able to appreciate that when I actually explain you the entire use case. So this is a post-Obamacare Act. Obamacare Act is one act which President Obama introduced in the US healthcare market, and it was done with the intention of reducing the healthcare expenditure, which was a burden on the insurance companies and the government of US. So they wanted to reduce that healthcare burden without actually compromising on the care being given to patients. So it's really a huge problem that the government had. So in order to solve this problem, after a lot of study and analysis, they decided to start off something known as accountable care organizations. Accountable care organizations, these are organizations which are predominantly where the working staff are nurses, senior nurses, because people who come from the nursing profession after a particular age of 45 or whatever, they actually may not be or may be effective in their job of taking care of the patients. So typically they migrate to a role as a care manager, and an accountable care organization is predominantly driven by care managers. So accountable care organizations can be the responsibility of different kind of organizations, but predominantly what you see, accountable care organization is driven by the payer or the insurance company, or it could be driven by the primary healthcare organization, which is like a large hospital present in a particular area. Or third, it could be driven by a community of people who are living there. For example, if I can take an Indian context example, let's assume all of us staying in area X of Hyderabad decide to start an accountable care organization as a community driven organization. We can actually do it. We are allowed legally to do it. Or it could be an organization started by any of the large health insurance companies specifically to monitor the health of people in our area of residence. Or it could be also driven by a hospital which is present. Let's assume that like a hospital like an Apollo or anyone is present in an organization, they can also start an accountable care organization. So now predominantly the accountable care organization's responsibility is to ensure the well-being of people in the area, and predominantly they look at chronic healthcare disease patients, because chronic healthcare disease patients such as patients suffering from diabetes, hypertension, asthma, obesity, these are people who are actually creating a burden on the healthcare budget of the insurance companies or the healthcare budget of the US government. Okay, and if these people end up in an emergency room situation and they end up in the emergency room of hospitals, it's likely to cause a huge expenditure. So the entire focus of the accountable care organization which we were interacting with, their responsibility was to ensure that asthma patients, both pediatric and old patients, do not end up in an emergency room kind of a situation. So that was the business context, and we decided to build them an intelligent alert system. When I say intelligent alert system, so we were analyzing data from multiple sources for this project, and the multiple sources were healthcare parameters which are coming from internal to the ACO. These are health parameters like the diagnostics tests which the patient has actually given samples for. Second could be data which is collected on the environment and especially related to the pollution, because asthma patients are very susceptible to pollutant levels in the air, which is the pollen level in the air, the NOx, nitrogen dioxide levels in the air, the carbon monoxide levels, the sulfur monoxide levels. So we were collecting this data from government websites like Environmental Protection Agency. We were also asking our patients to wear some health devices like Fitbit or anything which helps us to monitor their physical activity on a daily basis. And they were also incentivized to actually through an app enter information in terms of what kind of food they are intaking and how much dosage of medicine they are taking, how they are modulating that. So they were also incentivized to give us this information on a daily basis. So this was all the different kind of information which we had. So we had actual data coming on the diagnostic tests. We had data which is coming from third-party agencies on the pollutants or anything. We had data in terms of their health parameters coming through wearable devices, and we also collected other parameters such as their compliance to their doctor visits and everything, because these are patients who are suffering from chronic care. So how frequently are they going to the doctor, and when did they make the visits and stuff like that. So combining all this data was the first challenge which we had, and after combining all this, we analyzed the data and built a machine learning model which was actually giving intelligent alerts. Okay, and the intelligent alerts was here. If you look at it, we were predicting the probability whether a patient is likely to end up in a hospital in an emergency room situation or whether he is not likely to end up in an emergency room situation. And once we actually predict whether a patient is going to end up in an emergency room situation, this used to come up as an alert in the care manager. As I mentioned, care manager are nurses who are part of the accountable care organization, and each care manager was responsible for handling the health of at least 1500 patients. Alright, so these people used to get an alert on a particular patient that, hey, we feel that this guy is going to end up in an emergency room situation. That used to be a machine learning driven insight. Not only we used to give the machine learning driven insight, we also used to give evidence why we believe this guy is going to end up in an emergency room situation. Like the evidences could be something like as simple as, hey, he is not doing his exercises regularly, or it could be like his levels in the last 2 months of tests were on the higher side. And we just give this evidence, and then the care manager, using his expertise as a nurse and who understands this chronic disease, used to intervene with the patient and ensure that he takes some preventive action or does some action which reduces his chances of ending up in the emergency room situation. So this was one healthcare example of an application like population health which we implemented as part of my previous work experience in the healthcare domain. Similarly, if you look at the financial service industries, there are a lot of applications. Financial service industry has been using data science or any machine learning tools way back from the last 30 or 40 years. Okay, machine learning or anything like logistic regression, decision trees, these are used especially in the retail banking and also in the investment banking side to suggest some business action which results in either reduction of cost or increase in revenue. One example I can take, if you take any retail banking example, let us assume that you as a retail banking or a marketing manager, you would want to create a campaign of personal loans, and before creating that campaign of personal loans, you would you would want to understand the probability of a person responding to a personal loan campaign on a phone or an email, because you want to understand that in order to reduce your expenditure on the marketing campaign. So before that, you can ask your team of data scientists or data analysts or business analysts which you have to build this model for you. They will actually take data from multiple sources within the organization, external to the organization. When I say within the organization, it could be data related to savings bank account. It could be data related to his credit card spend or credit card payments. When I say external data, it could be his credit score data which is coming from third party agencies. It could be his demographic data which is again the bank is collecting in terms of his location or the kind of company which is belonging to. It could also be like what is his salary and stuff like that. All these parameters from multiple sources are actually captured, and then they can actually build a machine learning model to predict whether the propensity or the probability of the person to respond positive to the loan campaign. So this is one example of an application of financial services. There could be several other applications in the area of suggesting investment strategies. Okay, whether to what is the ideal portfolio which you people should have. Okay, so and there could be other areas like who is going to default or do a default on the payments, and there could be other applications of financial services in terms of fraud, like credit card fraud or any other banking fraud. We can actually predict. A machine learning model can be used to do that. Apart from financial services, if you look at internet marketing companies, again there are huge applications which are already there. All of us, I'm sure, we have used internet websites or apps such as YouTube, Amazon and so on. In all this, whenever we go into YouTube, there are recommendations which are given in terms of videos. This is again a machine learning example. There are two kinds of recommendation engines. One is a collaborative filtering based recommendation engine, other is a content based recommendation engine. In both these applications, in content based, people understand what is our unique taste and try to recommend videos or try to recommend to us products or try to recommend to us some form of content which is very specific to our likes and preferences which they have been able to understand based on a past behavior. In collaborative based filtering, it's a different kind of approach where we say, hey, this is a guy who likes this, he is similar to another person who also likes something similar, the other person liked an XYZ content or a product, so let us recommend this to him. So that is another application, especially the recommendation which keep coming to you in terms of videos when you see in YouTube, or recommendations come to you in Amazon in terms of a product recommendation, is purely based on this application. So that's another application where the building of the application could be on small data, but definitely the application will be on big data. So this is an application in the internet marketing space. Similarly, if you talk about the telecom industry, churn, attrition modeling, okay, or customer segmentation. Attrition modeling, because telecom industry, especially in the prepaid customers, they have customers who actually take on their come in as a customer, but within a short time span of 3 months to 12 months, they actually exit from the company and take up a SIM of card of another company with the same number, especially the number portability. So can you build a machine learning model to predict which customers are likely to leave your company or take up a SIM card on another company with the same number? If you can do that, then you can actually intervene by giving some marketing strategies and ensure that it does not leave. So this is also some very useful use case in the telecom industry. Apart from this, there are use cases even in the travel industry. There are use cases in every industry. Nowadays, data science is becoming mainstream. Both small, mid-size and large companies, all three different kind of organizations are looking to see how they can actually use data to compete better and how they can use data to develop a strategy which cannot be, which will give them an advantage of their competitors or rivals. So data science has huge applications, and people who are actually being employed in this area, they have a challenging area of domain to look at, that they can take it two approaches over here. They can work in different problems across different industries, or they can even choose to work in one industry and become an expert not only in data science or AI, but also it's specific to that industry problems where they have solved different kinds of problems specific to the industry. Like if you take financial industry, there's so many different problems. If you get exposed to all of them, you're really going to be someone who's going to be valuable. Thank you.